mathematics. How much gold can you hold in an elephant's ear? When it's noon on the moon, then what time is it here? If you could count for a year, would you get to infinity or somewhere in that vicinity? When you choose how much postage to use, when you know what's the chance it will snow, when you bet and you end up in debt. Oh, try as you may, you just can't get away from mathematics.
Good morning, grade 11th. It's Wednesday, June 3rd. Welcome back. I hope you enjoyed doing just a little bit of work yesterday, reading a little bit about critical angles and the dispersion of light and how mirages are formed. Hopefully that was a little bit interesting for you. With the critical angle, if you were here, I have a really neat little demonstration that I could show you where we could see critical angles and how it happens. But just know that when the angle of incidence gets large enough, instead of refracting through, we can have light reflecting off of clear surfaces, and we experience that all the time when we look over a lake and we see the nice reflection of the trees, right? That's because the light rays are reflecting off the surface of the water. Or when we look at windows and we see a reflection off the window, again, that's because light rays are reflecting off the glass rather than going through it. The angles are such that we are getting a total reflection, internal reflection. All right, as we move on to today, we want to talk about lenses today. And so just like with mirrors, there are convex and concave lenses. And the properties are similar. In fact, the formula is exactly the same. The lens formula is the same as our mirror's formula. And so we're going to continue using the same formula for these. And the rules for drawing them, the rate rules for drawing these diagrams are the same as well. But what we have to remember is basically what a convex lens is it's two convex pieces placed together. All right, and so what that does is it gives us focal points on both sides, and it gives us centers of curvature on both sides of the lens. And so when we draw this, and I'm going to try to draw this as best I can, the rules are the same. Light rays that are parallel to the principal axis. And what we do when we draw a light ray refracting through a lens is we draw it to the center line of the lens. Okay? It's not exactly what happens in a true lens because it's not exactly like that, but it's close enough that if we go to the center line and we refract it, it's going to get refracted through the focal point. Okay, again, remember when we did reflections in mirrors, rays that were parallel to the principal axis got reflected through the focal point. Now we are going to be refracted through the focal point. The second rule that we always used was the one that a ray that went through the focal point got refracted parallel to the principal axis. And so that gives us an image over here, right? And so this would be considered a real image. Okay, now, convex lenses will only give real images. Always, 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 they can never give you a virtual image because the light rays are going through and they're converging to a spot, giving us a real image. And it will always be inverted as well. Okay, so those of you that wear glasses, this is what's happening with your glasses. You change where this is, you change the focal lengths, and it does produce an inverted image, which then your eye and your brain flip back over. It's amazing how that works. But it is exactly what happens. Now, if we go to the concave one, it's similar, except now, when we put our image here, the rays that come into parallel will get refracted such that it goes like that, where we project this backwards on this side. Okay, and this one that comes in through the focal point, okay, right to there, will go this way, but it will get projected back this way, giving us an image in there, in and about there, all right? And so with concave, we will always get virtual images. Okay, now sign conventions, positives and negatives with lenses are a little bit important and they can be a little bit tricky. All right, so over here, this would be a positive object distance and a positive image distance, okay? Because it's real, okay? This is a real object, so it's a positive distance, and a real image, which is going to be a positive distance. Over here, we're gonna have a positive object distance, because the object is real, but we're gonna have a negative image distance, because the image is virtual. All right, so basically, real objects and real images are considered positive distances from the lens. If it's a virtual image, then it is a negative distance from the mirror. All right, and then again, these would both become negative heights because they are inverted. And that sign convention is the same. If it's above the principal axis, it's the positive height. Below the principal axis is a negative height. All right, the formula is the same. 1 over f equals 1 over dO plus 1 over di. That does not change. There is also a magnification quality, and again, that doesn't change either. Okay, magnifying glasses, right, use this property. And again, it's the same formula. Magnification equals hi over ho equals negative di over do. All right, so same formulas, same rules for drawing diagrams, except now the light rays are going through the lens, being refracted rather than being reflected off of a mirror. The questions are the same. You're going to get the same kinds of questions, except it'll say something like an object is placed 32 centimeters from a convex lens. Find it with a focal length of 8 centimeters. Where is the image? All right, so we're going to use the same formula, right? We have a focal length of 8. Said we had an object distance of 32. Where's the image? Okay, so again, same formula, same kinds of questions, just lenses instead of mirrors. We're going to split the assignment up into a couple different parts. So today you're going to do a thing out of your textbook. There'll be 4 or 5 questions out of there that you can find on Connect. As always, if you have questions, send me an email and ask, and we will see you tomorrow. That's all I have for you today. Have a great day.